We're going to work through some problems that deal with adding and subtracting rational expressions. So for instance, just as an introduction, let me show you the kind of, this is actually out of section 1.4 in our books. So we have a problem like this. I'll just give a fairly straightforward problem. We have two rational expressions, and we're going to try and, in this case, subtract them. First thing I want you to realize is this is an expression. This is not an equation. Later on, we're going to have something like this, except it's going to be an equation. An equation would look like this. If it's an equation, we're going to solve it. However, we have an expression. All we can do is simplify the expression. In this case, that's going to involve simply subtracting these two rational expressions. About 98% of the time, when we're adding or subtracting rational expressions, the final result will also have the variable in it. When you solve an equation, the solution will be a number, or maybe two numbers. But when you simplify these expressions, you're going to end up with variables still. Now, I won't go through all the steps, but we're going to see that to simplify these expressions, the first step is always to factor, and the second step is to find the LCD, which is short for lowest common denominator. Now we've already gone through, I've already put together some videos on factoring. So we are going to factor when we solve some of these problems, or when we simplify these expressions, but I'm not going to take the time to describe factoring. The goal of this video is to talk about the second step. When you're given rational expressions, how do you look at them and find the lowest common denominator? It can be a little tricky at first, although once you do it for a while and get the hang of it, it's not too difficult. So, as a way of introducing, let's think back. Instead of looking at rational expressions, let's think back to when you first learned to add or subtract fractions. Maybe back in, who knows, 3rd grade or sometime in your elementary school years. Say, for instance, you were given the problem 2/3 plus 1/4. And you learned way back then you cannot add fractions unless you have a common denominator. So you would go find a common denominator. So you look at the 3 and the 4, and you would ask yourself the question, I need to go find a number, the smallest number that 3 goes into and that 4 goes into. And I think almost all of you would know that the LCD would be 12. Now let me just show you how you did this problem way back when. And you may not even realize you did this, because now you know you do it instinctively. What we're going to do now is take that first fraction, and I'm going to change it from having a denominator of 3 to having a denominator of 12. I can do that if I multiply the top and the bottom by 4. Or in a sense, I'm multiplying that fraction by 4/4. I can do that because 4/4 just equals 1. So I haven't actually changed the value of 2/3, it just looks different. So 2/3 turns into 8/12. And then I do the same thing for my second fraction. I'm going to go from a denominator of 4, I want to get to my LCD, which is 12. In order to do that, I multiply by 3, but I have to multiply the top and the bottom by 3. So now 1/4 becomes 3/12. Now I can actually add these two fractions. And you remember when you add fractions, you write the common denominator and then add the numerators. So 2/3 plus 1/4 would equal 11/12. We're going to do the same thing when we add or subtract rational expressions. But what this video is going to talk about is how to find the LCD for rational expressions. Here we found the LCD when our denominators are just two numbers. Now we're going to look how to find the LCD for rational expressions. So in all these problems, I will first write out the problem with denominators, but I will just make the numerator 1. So for instance, here's the first problem I want to do. So I'm going to take these two rational expressions. I'm actually not going to add them together because the purpose of this video is just to try and show you how to find the LCD. Later on, there'll be a video where you actually add or subtract the expressions. So here's a case where we have two fractions. The first has the denominator of 18x squared y cubed, and the second has a denominator of 25x to the fourth y to the fifth. In order to find the LCD, the first thing I do is factor, but nothing factors here. So now I'm basically looking at these two denominators, and I'm saying, what would the LCD be here? Now let me tell you how I like to think about finding these LCDs, and maybe this will help you. First of all, I sort of have two problems here. I've got two numbers, or two coefficients, the 18 and the 24. And then I also have some variables, x's and y's. And actually, you know what? Just because I wrote this problem down, but because I'm trying to teach you the principle of it, I'm going to make this a little simpler, because the whole key is not to have difficult numbers. The whole key is just to show you the method. So I'm just going to change it to 6x squared y cubed and 4x squared y to the fifth. All right. So I'm changing it on the fly because I'm trying to teach you the principle. I don't want you to get hung up on having numbers that may be a little bit more difficult. So I have two things going on. I got some coefficients, a 6 and a 4, and I got some variables. The 6 and the 4 I'm going to treat just like adding two fractions, 1/6 and 1/4. Just what I showed you 3 minutes ago. If you have 6 and 4 as your denominators, what would the common denominator be between 6 and 4? It'd be 12. All right, so that's the common denominator for the numbers part of it. What do I do for the variables? And for the variables, let me just describe how I like to do it. I like to use this phrase, combine but don't repeat. And maybe see if I can describe to you what I'm talking about here. Combine but don't repeat. Easiest thing to do is I'm going to go and now write down, now this is just the variable part. I'm going to have to combine it with this 12 in a minute, but for the variable part, I'm going to write down the denominator of my first fraction, the whole thing. So for me, it's x squared y cubed. And then I go look at the second denominator, and I look at the x, and I say, so far in my LCD, I have an x squared, but I look up here to my second denominator, it needs to be x to the fourth. what I do is, since x to the fourth is larger than x squared, I change this to x to the fourth. And when I look at the y's, I have y to the third, but the second denominator needs y to the fifth. So now it becomes y to the fifth. It's almost like you look at these two denominators and in this case you have to look and use the largest exponent. When I look at the x's, I have an x squared and an x to the fourth. I use the x to the fourth. When I have a y cubed and y to the fifth, I use the y to the fifth. So the overall LCD for this problem would be 12 x to the fourth and y to the fifth. So what's really going on is now when you look at your LCD, you can look at your first denominator. 6x squared y to the third will go in to 12x to the fourth y to the fifth, and 4x to the fourth y to the fifth will go in to 12x to the fourth y to the fifth. So it's almost like you're combining these, but you're not repeating. Let me do a few more examples. This is sort of a unique example. Let me do some more, and I think as I do more of these examples, I think you'll pick it up. Here's a different kind of problem. So you had something like this. 1 over x minus 2 minus 1 over x. First of all, there's nothing to factor. Easiest thing to do here, now there's no coefficients, so now we're just dealing with these variables. And actually, when you have a denominator like this with addition or subtraction, you have to include this whole thing as like a factor. So I put the parentheses there. And here's what I do. I do my combine but don't repeat. I'm going to write down my first denominator. And I go to my second denominator and I say I'm going to need to have an x in my LCD. And I go look at my LCD so far, and there's no x by itself as a factor. There's an x in here, but this x in here is part of this x minus 2 factor. That's not the same thing as having x. So what do? I have to include the x. And now the LCD of these two denominators is x times x minus 2. Hopefully you can see I've sort of combined these, but in this case I did not repeat. How about another example? And I'm going to make it look similar to this, but just a little bit different. Well, it doesn't look the same at first, but you're going to see it's pretty similar. 1 over x squared minus 2x minus 1 over x. Okay, the first step here is factor, and actually there is something that can be factored. This denominator can be factored. So I'm going to say, I'm going to factor out the x. I have x times x minus 2 minus 1 over x. Now, my LCD, I'm going to write down the first denominator, the whole thing. And now I go to my second denominator and I say I'm going to need an x in my LCD. But I go here and I look, and so far, what is my LCD? I already have an x here. All right, it's already there. I don't need to write it again. I don't need to do anything. It's already there. So actually, I'm done. There's my LCD. Just to prove the point, what if I had had this? Same steps. You write down the whole first denominator, and then I go look at my second denominator and I say I need to have an x squared in my LCD. And I go look, And right now I have an x. Well, that's not good enough. It needs to be x squared. So what do? I need to make that an x squared. And then I have the LCD. And once again, the idea is x times x minus 2 is sort of embedded. It's part of this LCD, and x squared is also a part of it. We're sort of taking these two denominators and combining them, but we don't need to repeat anything. Let's just do a few more. How about 1 over 2y plus 8 plus 1 over y plus 8. First thing I do is factor. The 2y plus 8 actually factors. I can factor out a 2. And I'm going to go ahead and put parentheses around this y plus 8. So then the same process. My LCD, I write the first denominator. And then I go look at my second denominator. I need a y plus 8. I look. I don't have a y plus 8. I have a 2 and a y plus 4. So I go ahead and put the y plus 8 in there. And there's my LCD. All right, 3 more examples. How about one over x squared minus 81 plus 1 over x squared plus 18x plus 81. All right. Factoring. Do I need to factor? Yes. Matter of fact, both of these denominators factor. This first one is the difference of squares. Factors into x plus 9 times x minus 9. The second denominator is a trinomial, and it factors into x plus 9 times x plus 9. So now what would the LCD be? Just follow the same process. You write down the whole first denominator. X plus 9 times x minus 9. And now I go look at my second denominator. What does my second denominator need to be, or need to have? X plus 9 times x plus 9. You can actually think of that as x plus 9 quantity squared. I go down here and I look. I have x plus 9, but I only have 1. So in order to include this second denominator, I need to actually square this. And then there's my LCD. All right, 2 more examples. Here, I actually have 3 rational expressions. As a matter of fact, if you go and stick these in parentheses, then I look at this third denominator and I realize that can be factored. That's a difference of squares. Just to save time, let me sort of mark this out and rewrite this as r plus s times r minus s. And now, for my LCD, I have 3 denominators, but the procedure is the same. Let me write my first denominator, r plus s. I go to my second denominator. Second denominator is r minus s. I go see if I have an r minus s yet in my LCD. I do not, so I have to include it. I go to my third denominator. First, I need an r plus s, and I check. I've already got an r plus s. I also need an r minus s. I've already got an r minus s. Therefore, there's my LCD. And the last one, 1 over y squared minus 8y plus 12 minus 1 over y squared minus 6y. Let's find the LCD. First step, of course, is to factor. First denominator is a trinomial, and I believe it factors down into y minus 6 times y minus 2. The second denominator, I can factor out a y as a GCF, and that's y times y minus 6. Now my LCD, same procedure. I write down my whole first denominator, y minus 6 times y minus 2. I go to my second denominator and I check one factor at a time. Here I have a y, I need a y as a factor, I don't have one. So I go ahead and include it, I'll just write it out front. Then I need a y minus 6 and I look, I already have a y minus 6, so therefore there's the LCD. So hopefully this method will help you, and what's going to happen is, after you do this for a while, you'll sort of get the hang of it, and then for the most part, you will look at rational expressions, and once you factor them, you almost right away will be able to write the LCD. You will not even need to go through this procedure of writing the first denominator and then checking the rest. But at first, if you're not sure how to do it, it's a great way to get started.